Hey everyone, welcome to Unit 9.2. Today we are solving exponential equations. So the first thing we want to know is, what does an exponential equation look like? So we're going to have our variable as the exponent now. Okay, so you can see the difference between example 1 of x squared and example 2 of 5 to the x. The variable has, the exponential equation now has the variable in the exponent. Okay, in the first one it occurs as the base, and then in the second one it is the exponent. So we have properties of equality when we're dealing with exponential equations. So that means when the base, so that's the big bottom number, when the base on each side of the equation is equal, we can cancel those out and the exponents can be set equal to each other to form an equation that we can solve. Now we're going to have to use our exponent rules in order to solve these equations. Okay, so we always want to try and make the bigger base match the smaller base, okay? And we can use a factor tree to do that. And our second trick here, okay, anytime you have numbers written as a fraction, we want to remember our exponent rules, okay? And anytime we have something in the denominator of a fraction, we can bring it up to the top. And all we have to do to make it equivalent is change the sign of our exponent. So something like 1 over 8 squared is the same thing as 8 to the negative second power. Because it went from being in the denominator, we then brought it up to the top of the fraction. We could consider this being 8 to the negative 2 over 1. And those are now equivalent, and we're going to want it written this way where it's not in the denominator, so that we can solve an equation. Okay, so we'll start off with some easier examples. So number 1, okay, we have a base of 2 and a base of 8. So we want to take the larger base and we want to write it in terms of the smaller. So that means we're going to take 8 and we're going to break it down into a factor tree. Okay, and when we can't break it down anymore, we're going to say that 8 is the same thing as 2 to the third power. So we're going to replace just the 8 with 2 to the third power, okay? But that quantity is still being cubed. We have to keep that. And we have 2 to the x on the other side. So we've just created a power to a power situation here, and if we remember our exponent rules, we multiply when we're on the outside of the exponent like that. This is 2 to the x. Okay, so now we see that the base is the same on either side. We can cancel those out, and the exponents form an equation that can be solved. Well, this is already solved for us. So we have an answer of x equals 9. Okay, we'll try it again. So in example 2, I have a base of 9 and a base of 3. So we're going to break down the larger number to look like the smaller one. Okay, so I break down 9, and 9 is the same thing as 3 squared. So I'll change out just the 9, and I'll make that quantity 3 squared, but then I want to keep the rest of the equation, or the exponent over there, exactly the same. Okay, and again, we've created a power to a power situation. So we're going to distribute this time. So it's going to be 3 to the 4x minus 2 equals 3 to the 6x x. Okay, and you see we have a base of 3 and a base of 3. So we can get rid of those and make an equation out of our exponents. So we do have to do a little solving for this one. And we're able to solve our equation. Now sometimes you might have to break down the base on both sides of the equation. So we look here and I see, okay, a base of 16 and a base of 8. So rule of thumb says break down the larger number. All right, I'll take 16. 16 is 4 times 4. Well, that's not a base of 8. So what is 8 going to do? Well, 8 doesn't even go to 4 and 4, which means I have to break down each number more and more until they come to the same base. So 16 is 2 to the 4th power, and 8, we saw in a previous example, is 2 to the 3rd power. So we had to break them both down pretty far so that they came to the same number. So we'll replace each of those. So 16 is going to be replaced by a 2 to the 4th. But remember, the exponent stays the same. And then the only thing on the other side was the 8. So now all we have is a 2 to the 3rd. I'm going to simplify my power to a power, so I get 8x minus 12 and 2 to the 3rd. Okay, so the same base allows me to cancel. Okay, and I'll just leave that as a fraction. Okay, so that was breaking down the base on both sides. So you could always start with the larger one and see if you can make it look like the smaller one, but you did that first step, right? We broke it down into 4 and 4, and we said, well, there's no way that I'm going to make that into an 8, and I can't make an 8 all out of 4s. So I had to reassess here and break down both numbers. Okay, the last example that we want to look at is with this fraction. Okay, so the first thing I would suggest is taking this large number of 243, okay, and we want to break that down. Okay, so 243 is 7 to the 3rd power. Nope. No. What am I doing here? I'm all turned around. Thinking it's 343. 243. Okay. So I'm going to do 81 times 3. This is 9 and 9. Okay, so 3 to the 5th power. God, what am I doing here? Okay, finally getting it together. Here we go. So I'm going to replace this with 3 to the 5th power. Okay, so one of these is in the denominator and the other one is not, which means we want to take this entire thing and we're going to bring it up to the top of the fraction. But in order for it to be equivalent, let's do some exponent rules and change that sign. Okay, so that's a very important step. We'll put a star next to that. When it comes up to the top, you have to change the sign. And if we forget to make that change, Well, that's obviously going to affect our equation now when we go to cancel out the base. All right, so those are all of the situations that you could encounter solving exponential equations. Okay, please make sure you have all of those examples complete, okay, and any notes that we talked about for each one of them. Okay, and we're going to do some more practice with this the next time that we're in class. All right, thanks so much for watching, guys. I'll see you soon.